Hey Lexi, I'm going to take a look at this problem with you so that you can hopefully finish up lesson 95 today. This is actually lesson 95, number 20. And I wanted to take a look at this with you. It's not as difficult as it might seem. So let's see what we can recall with this. Now there is a theorem that you will apply to this problem. And I'm going to look that up right now. Theorem 74, if you'll pull your packet out and find theorem 74, you'll go back to, in your packet, page 765. And this is theorem 74. What in the world happened there? Theorem 74, let me write it right here. Theorem 74 says that the measure of an angle that's formed by two secants, which we can clearly see we have two secants right here, one here and one here, just mark them in yellow. So the measure of an angle that is formed by two secants intersecting in the exterior of the circle. So let's think about that. Two secants that are intersecting in the exterior of the circle. So here's where it's intersecting, and that is on the exterior of the circle at point M. The angle we're referring to here is angle X, which would be placed right in there. So again, let's say that again. So the measure of an angle, which is right here at X degrees, formed by two secants intersecting in the exterior of a circle is equal to 1/2 the difference of the measures of the two intercepted arcs. So what are the two intercepted arcs here? Get rid of some of this stuff here. So the two intercepted arcs, I'm going to mark those, excuse me, I'm going to mark those in a different highlighting color so we can see it a little better. We'll take pink, see if that helps. The intercepting arcs, one is here and one is here. Remember, the arc is a part of the circle or portion of the circle. So if we take 1/2 the difference of those two intercepted arcs, that will give us the measure of X. Well, it's not as easy because I don't know the measure of this intercepted arc over here. But once I do know it, so let's kind of set this up. If I were to write this out with just the information I currently have, theorem 74 says I'm going to take the difference of the two intercepted arcs. So I would take, arc IJ, and I would subtract, because difference means the answer to a subtraction problem. I would subtract the smaller arc. Still, excuse me, I'm still fighting with my voice a little bit here this week. So the two arcs, we take the difference of those, but we're going to divide that by 2, and that's going to give us X. So you want to write that in your notes. Well, let's figure out how do I know what because I can't really go any too far because I actually technically would have two variables here, wouldn't I? I would have this variable, X, and really, this is still a variable because it's unknown. So I need to narrow this down to one variable. Well, let's figure out what IJ must be because we do have information to figure that out. So let me highlight in a green, see if that helps here. Okay, notice something about this segment and this segment. We're told by this little tick mark that these are congruent segments. Well, I want you to think about that with me for a minute because if I had a circle, for example, watch this. If I had a circle out here with two chords in it, and that's what those green segments that I just colored in are. Those are chords, right? Because they're on the inside of the circle. If I had two chords in there that look like this, for example, you can clearly see that those chords are not congruent. And if those are not congruent, then their intercepting arcs are not congruent either. Okay, but if I have two, like in the problem above, if I have two chords that are congruent, well then their arcs must also be congruent because they're cutting the circle in the exact same way. Okay, it stands to reason that if your chords are equal, then the arcs that they have intercepted are also going to be equal. So let's say then if that is true, then that must mean that this is 110. Okay, so the two intercepted arcs I just talked about is this one here I'm doing in yellow, and this here. This is going to help us find that one in pink over there with the question mark, IJ. Because what is the complete circumference of a circle is 360 degrees, right? Let me get rid of this here. So let's figure out this missing one that's over here. So if I have 110 as part of the circle, I have another 110 that is part of the circle, and I have 50 that is part of the circle. What do I have here? 220 and 50 is 270, right? Okay, so 270, but I need to figure out the missing part, and that has to total 360. So if I take what the total's supposed to be and subtract out what I already know, I'm going to end up with 90. Okay, so this arc over here is 90 degrees. Now I have what I need that I can put into this equation. So I'm going to rewrite it right below. So IJ we just discovered is 90. We'll finish out the equation here to solve for x, which is the angle we're looking to solve for. So I have 40 divided by 2 equals x, equals x, and x is going to equal 20 degrees. So that is the answer to number 20 in lesson 95. I hope that was helpful. If you have any questions, hold on to them. You'll probably see a problem like this pop up again, so make sure you make these notes inside your notebook. All right, my dear, talk to you later. Have a good day. Bye-bye.